The next thing to do is to start testing our hypotheses. So let's go find those hypotheses. Now you have a lot more than I do, but I'm going to test these three. First one is a mediation hypothesis. So to do this, we first need to build a new model in Amos. So open up Amos, and let's build a new model. So File, New, and the data set we're going to use is that one we recently saved. Let's just make sure it's fully saved. Saved, here we go, it's the one with cooks at the end. Go load that data set, grab it over here, cooks, okay, and let's build the model. Just there we go. Okay, it is information acquisition as a dependent variable, decision quality as a dependent variable. And let's start drawing some lines. Is that it? Notice I don't have an arrow from atypical use to information acquisition or from playfulness to decision quality. Let's see if that is accurate. Let's go back to this model here. Here we go. Yep, that looks good, except I'm missing arrows from usefulness to decision quality and joy to information acquisition. Okay, let's make it look good because we can. Move this a little bit more and resize observed variables. There we go, they're all the same size. I can zoom in a little bit and let's put residuals here, 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 and here. Anything that's being predicted needs a residual, name, unobserved, and we need to covary the exogenous variables here. Now we also have a few other exogenous variables. If we go back to our model, we have age and frequency. We need to stick those in from the get-go. So age and frequency. Here we are, age, whoa, and frequency. Those are enormous. Let's go back to view, interface properties, miscellaneous, display variable labels, uncheck that, apply, and again resize, plugins, resize, observed, there we go. Okay, now we need to covary these with our other exogenous variables, so let's do that. That does get a little bit messy, but it is an assumption of Amos and of covariance-based methods that you will covary all exogenous variables. Now, there are different schools of thought on how to include controls, whether you must control for these for the effects of these variables on every endogenous variable, or if you can do it just on select endogenous variables. In this video, I'm going to say you can do it on select, but you may want to check which is the preferred method in the journal you're publishing to, so that you're not breaking their rules. Okay, so I think age could affect decision quality and information acquisition, and frequency could affect joy and these other guys here. Okay, notice I did not regress age on usefulness or joy, and I didn't regress frequency on usefulness. Okay, I'm going to once again select all and try to make it pretty. It's hopeless, just too much going on. Okay, here we have it. That's our ugly model. Save as path mediation. Now recall, these are CMB adjusted or corrected variables. So the common method bias we observed in the measurement model is being accounted for in these variables. All right, first thing to do when doing mediation is to check for model fit. In fact, the first thing you do whenever you test any hypothesis is check for model fit. I should probably, there's a new figure I have on my StatWiki. Let me show you. If we go to the SEM section and we go to this one, here we go. There's this thing called global versus local tests. You must meet global tests in order for local tests to have any meaning or validity. So a p-value, while it might be significant, is useless if you don't have model fit, because there might be some alternative explanation. Or a p-value might be useless even if it's significant if you have a very low R-square, meaning you haven't explained sufficient variance. So back to this. We need to assess model fit first. Let's run this. It says you haven't covariate age and frequency. I need to do that. Let me covary those. Age and frequency. All right, run this. There we go. Hit the up arrow if you want, and look at standardized estimates. We can just start exploring. We didn't do standardized estimates. Let's go ahead and check the box for that. Standardized. I'd also like to see modification indices and squared multiple correlations, the R square. Okay, save that, run it, up arrow, and we can just begin exploring a little bit. Okay, some effect, no effect, lots of effect, lots of mess, so some effect, moderate effect. Interesting, our control probably has an effect frequency on joy. That's interesting. No other real effects from controls. Some effect, some effect, some effect. I think I'm missing a path from playful to joy. Yes, I was supposed to have that. I don't have that. Let's insert that. Playful to joy. There we go. Run again. And yeah, some real effect. Cool. All right, let's do this. Let's go to the output and check for model fit. Model fit. And what does it say? It says, you shall not pass. Oh no, CFI of 654. That is horrendous. That is awful. So let's go look at modification indices. What seems to be the problem, officer? Ooh, E2 and E3, 167. That is crazy. What is E2? What is E3? E2 and E3, information acquisition and decision quality. Says these two things are highly related. If you look at Dave Kenny's website, he says if you're going to covary the DVs, you might consider covariating the mediators error terms. So let's think about this logically. Should useful and joy be correlated? Maybe. They're both positive constructs on this context, so there might be a relationship. Let's see what our modification indices say. But first, model fit. Oh, that's better. 0.94. In fact, that's almost good enough to move forward. If we look at the RMSEA, though, is 0.144. That's awful. P close is 0. So back to modification indices. And it says E1 and frequency. Not sure what we can do about that, but E1 and E4. Let's go look at that. Ooh, or go look at our regressions. It says you really ought to have something from useful to joy. Well, those are both our mediators, so that indicates that they probably should be covaried on their error terms. It also says frequency really ought to predict usefulness, and joy ought to predict usefulness. We're going to covary these error terms because it says those are definitely related, and that will help to account for that shared variance while still allowing us to predict with these other variables. Okay, run that. We only do one at a time. Go look again at model fit. 969, that's better, but it was the RMSEA we were worried about and still awful. Go look at modification indices, and it says, well, frequency really ought to be controlled for on usefulness. So let's do that. Frequency to usefulness. And you may say, whoa, James, you're changing your theory based on the statistics. This is just a control variable, and it says if we don't control for it, anything we do find is invalid anyway because we don't have a model fit. So better control for it and slightly modify our theory here. Okay, run this. Hopefully we're good now. We're running out of degrees of freedom here pretty fast, so that worries me. Model fit, CFI of 1, yikes. But RMCA is done at 0. Now, what if you're not comfortable with that? What if you're not comfortable with a CFI of 1 and your reviewers aren't comfortable with that either? Well, what we could do is go and delete paths that are not significant. That would free up some degrees of freedom, particularly from the control variables. So I will do that now. Now, if you had a fully latent model, this would not be a problem. You would have tons of degrees of freedom because you have a measurement model involved. But with a path model, it gets a little bit tricky. So let's go look at those controls. From frequency, we have no significant effect on information acquisition or decision quality. From age, no significant effect at all on anything. So, do we just delete age? Not yet. Let's do things one at a time. Age has no effect on decision quality. I'm going to delete that. Now, you might report that you did this. You say, The effect of age on decision quality was, and you list that effect right here, because it had no effect different from 0, because its effect was no different from 0, we opted to delete it in order to free up a parameter, in order to gain a degree of freedom, because we were using a path model. So we did that. We ran it again and went and looked again at model fit. CFI is still 1. Scary. So we go look at the estimates again and look at information acquisition and frequency. No effect. Same logic here. Frequency, information acquisition, no effect. Run it again. Model fit, still a problem. Go look at estimates and age and frequency. We have 187. So that one's kind of borderline. Age on decision quality is borderline. But from frequency, let's look at these other frequency ones. Significant, significant, can't get rid of those. So we will look at this one and consider deleting it. Let's go ahead and delete it for now to see if it has any effect. Frequency on decision quality. Run it. Look at the output. We have 7 degrees of freedom now, getting better. Our model fit, still ridiculous, ridiculously perfect, you might say. I'm gonna call it good, I think. You can see that the effect of age on decision quality is now significant at the 90% confidence level. And all other effects are significant except we have here atypical use to decision quality, atypical use to joy, no effect, atypical use to usefulness. In fact, atypical use is fairly useless. Wow. But that might change based on gender, so I hesitate to remove it. So here we are. We have good enough model fit. Next thing to do is run mediation tests, which I will do in the next video.